I am your host, Mr. Sindel, and today we are still waiting for Leo, who is taking longer than 30 seconds in order to get his water, but we are on lesson 4-2. Today's date, write it down with me, is Tuesday, October 29th. All right, so, quiet raised hand, objective, who's got it? First hand, Ellery.
Use long division or synthetic division to divide quadratics by linear expressions.
All right, hold on here. Long division. So, you guys know how to do long division. 11 goes into 136. How many times to begin with? Quiet raised hand. I see one hand. I see two hands. I see three hands. Only 3 people know how to do long division. We'll give it to India.
Okay, so the first thing is you can't divide 11 into 1, so you put a 0 on it, 1. And then you can divide 11 into 13 one time, and that will go, you'll get 2 left over after doing subtraction.
All right, perfect. So that is the first step. Let me make sure that everyone can follow along, and I can zoom in here for the people that are in the back. 11 goes into 13 1 times, and then I do 1 times 11 to go beneath. 1 times 11 is 11, and then I subtract to get 2.
And then you bring down the 6.
What?
All right, so let's look for another quiet raised hand. What is the next step? Quiet raised hand.
Get out of here.
So Leo, if you can't drink your water quietly, then I'm going to make you throw out your water. Is there a quiet raised hand that can tell me the next step here?
Can you stop?
All right, Leo, you get back to the lesson. The next step with a quiet raised hand is to do what? It looks like Sam has a quiet raised hand.
Oh God.
Wait, do you bring down the 6?
You do indeed bring down the 6, so this becomes 20.
Why was everyone laughing?
Because he said to bring down to 3.
She says bring down the 6. She's good.
She said 6.
Maybe you
Before she was like, "You bring down to 3."
Let's please be respectful of each other.
Right, Caroline? Yeah. See, you were laughing too.
All right. Thank you for being negative to each other. You guys know what happens.
Please don't punish me. Just makes me feel worse about myself.
All right. Onward. Next step. Quiet raised hand.
Wait, why are we going over like division? This is like.
Because there's going to be a very clear metaphor when we do division that's harder that looks like this.
Oh, okay. I just.
Next step, Beverly. Thank you.
11 goes into 26 twice.
Twice. All right.
And then next 22 on the bottom.
Why do I do 22 on the bottom?
Because
11 times 1.
11 times 2 equals 22.
Perfect. There it is. And then I'm going to subtract again, which means essentially I'm multiplying the bottom number. Jaden, please stop talking.
Sorry.
That is the wrong person. My bad, Chewy.
Whoa. Wait, nobody can protect me and I'm healing people out here? What's up with that?
Jaden.
I will stop healing. I will stop.
Brian protected you. All right, so from there, essentially what I'm doing is I'm multiplying this 22 by a negative to do 26 minus 22. 26 minus 22 is obviously 4, which means I have a remainder of 4. Again, the way that we write remainders in this class isn't by saying R4. That's how you do it in first grade, second grade, whenever you learn the long division. In my class, I say you do 4 divided by whatever you were originally dividing by, which is 11. So the answer is 12 and 4/11ths. Now let's apply this to polynomials.
Oh goodness.
Notice the similarity here. This is x plus 1. This was 11. Very similar. The coefficient in front of the x is 1. The constant term is 1. It's essentially 11, but in polynomial terms, I guess. All right, so how many times does x plus 1 go into x squared?
1 time?
It goes into it 1 time. It actually goes into it a little bit more. So if we look at our similarity, I need to figure out what times 11 will give me as close as I can possibly get to 13. So the new question that I have for everyone in this room, Chewy, is what times x plus 1 will give me x squared plus 3x? I'm trying to get rid of this first number. How do I get rid of x squared? What do I need to multiply this entire thing by a single term to multiply to x squared? Quiet raised hand. Who's got it? Beverly. It's a good guess. If I multiply by 2, don't write this down, everyone. If I multiply by 2, I'm going to get 2x plus 2. I need to somehow get rid of this x squared term, so I'm going to multiply by something other than 2. You want to try another shot, Beverly? X. All right, this is the correct answer. We're all writing it down. When I multiply by x, I'm now left with x squared plus x. Again, I'm multiplying x times x plus 1. And I'm getting x squared plus x. I'm trying to eliminate this first term by whatever means necessary. I have to multiply by x in order to do that. From there, I'm going to multiply this whole thing by -1, which means flip the sign of each term. If I'm flipping the sign of each term, this is now going to be a negative x squared and a negative x. I'm subtracting x squared plus 3x. I'm doing that minus x squared minus x. And I have the following. X squared minus x squared, shout out, is 0, nothing. Cross them off. They've been eliminated. Finally, this one is a quiet raised hand question. 3x minus x is what? I'm looking for someone that has their card. Does anyone still have their card? Caroline. It is indeed 2x. And then I bring down the 6, like before, 2x plus 6. Oh look, 2x plus 6 is very similar to 26. The metaphor is there. What now do I need to multiply x plus 1 by in order to get rid of this term 2x? Quiet raised hand. Who's got it? Who still has their card, by the way? What do I multiply x plus 1 by in order to eliminate this 2x? I'm seeing the same people over and over. Ellery?
2.
By 2. By a positive 2, right?
Yeah.
So I'm going to say x plus 2. So when I say 2, that means I'm going to multiply by 2. X plus 1 times 2 is 2x plus 2. Again, x plus 1 times 2 is 2x plus 2. And from there, I'm going to flip everything so they all become negative. So it's going to be negative 2x minus 2. And then I can just add them straight on. 2x minus 2x, shout it out.
0.
0. Is it a question or what is it?
Why are you multiplying everything by -2?
Why am I multiplying by every... So it's the same thing that we're doing back here. Why do we do minus 11 when 1 times 11 is really positive 11?
Okay.
I'm always subtracting the term. And I guess the conceptual understanding there, it's a very deep rule. It's something that I don't know if a lot of people would be able to get if I explained it. But I could try.
Yeah, try.
So the general way that we think about dividing in terms of just numbers is I need to find how many tens, how many ones, how many hundreds can I take away? Well, I can take away 1 hundredths. This is saying I can take away one of those hundreds. So that's why I multiply 1 by 10. And I'm taking away one of those hundreds, and I'm left with 36. That's not 36. 36. Because I've taken away tens of those, sorry, I'm left with 26. After taking away tens of these 11s, how many tens of these 11s am I taking away? I'm taking away one of them, and I'm left with 26. And then I have to figure out what goes into 26 from there. And that's exactly what you're writing down here. So similarly over here, you have what can I take away from x squared plus 3x plus 6? Sam, off task. What can I take away from x squared plus 3x plus 6, and how many do I have to take away in order to get a smaller reduced number? All right, so from here, I'm taking away 2x minus 2, so I'm going to be left with 0, as you guys all said, and then 6 minus 2 is 4, which means my remainder now is 4 over x plus 1. All right, you guys are going to be doing this again in example number 1. I'm going to be showing you the long division way, which I consider to be formal, dense, and difficult. I'm also going to be showing you a more conceptual way of doing this problem.
Is that easier?
It's, in my opinion, it's easier, but it doesn't work for every single problem. It's not a solid way that will always work. You'll have to adapt it to each type of problem. All right, so here is another example that I want you guys to work with me. I've shown you now how to do long division with polynomials. at least up to quadratics. Tomorrow is a quiz. The day after that, I'm going to do it with cubics, which is even harder. Yes, it is going to be hard, but I will also show you a nice little trick as well. So we're going to be doing long division. How do I set up this problem? X plus 3 is the number that I'm dividing by, so that means x plus 3 is the number that goes off here to the left. Go ahead and write this problem and give yourself some room. So this is going to be x plus 3. Give yourself some room right here to write your answer. Is it a question, India?
Wouldn't it be x minus 3, or is there some rule that changes?
I totally meant to write x minus 3. Yeah, extra credit point. Please log it. Colby, can you give her the 70 XP as well? All right, so Jaden, you've written x minus 3 already, right? And then from there, you're going to do your long division bracket and then write what's remaining. It's very important when you're writing these that you have descending powers. This goes to a power of 2, then 1, then 0, so I can write them all out. Sometimes you will need a placeholder. I'll show you that example down here on example number 3. Notice that this one goes x squared, 0x, then minus 20. You will need a placeholder because the x term is not there. Again, I'll repeat that again once we get there, but make sure that it goes in descending powers. So from here, I have 3x squared, minus 4x, minus 19. You guys are now going to tell me what I should be multiplying by first. What is the first thing I should be multiplying in order to get rid of this 3x squared? I see one hand. Can I get 2? I have 2 hands. Can I get 3? 3 hands. Where's more hands? What do I multiply in order to get rid of this 3x squared term? I still only have 4 hands. You have your card, Jaden?
Is it the same thing as the last problem?
It's very similar to the last problem. This x needs to be multiplied by what to get to 3x squared?
I don't want to say it because I don't want to sound stupid.
3.
It's okay, you still get your XP, even if it's wrong.
I want my participation
You got this.
card.
Being positive, yeah, being positive.
Is it,
Colby, if you want to give Sam her positive XP
is
points.
it the same thing we multiplied the last one by?
It's not exactly the same, it's a little bit different. Take a shot at it, Jane. You got this.
Is it 3?
So we did negative
Close.
1 on the last one, right? So is this one negative 3?
You're really, really close. It needs to match it exactly. So, Jaden, that's uncalled for.
That's why I didn't want to answer.
So, Jaden, you have it. I'm going to help you get it correct, though, okay? You wrote negative 3x, but it needs to match this exactly. If I multiply negative 3x by x, Jaden,
Yeah.
I will get negative 3x squared. I need it to match exactly.
Okay.
So in order to match exactly, I can't have a negative here. So what would you change your answer to? 3,
X.
3x. There you go. You got it.
Can you take my participation card still?
I can take it, yes.
That's all I want to do.
All right, someone give me a quiet raised hand. When I multiply by 3x, what do I get? What do I write underneath without doing the negatives yet? I only see 3 hands. What do I write underneath? If you know what you're doing, you can go ahead of me. You don't have to stay with us. What do I write underneath? Beverly.
3x squared
Which
minus
matches it?
9.
Minus 9x. Perfect. Thank you, Beverly, and you're getting your XP for that. Next, what is the next step? Something to do with the sign. Anna.
You put a negative, or I guess flip the sign.
Flip the signs, yeah. So that's a negative, and this one is going to be a positive. Perfect. And then you're just going to add them straight down. Once you switch the signs, can someone else do that for me? Another quiet raised hand. I want to get everyone in. I want to get that 100 XP bonus for getting all the cards in. India's a good backup. Is there anyone that still has their card? What do I do? I'm going to add these straight down. You guys got this. All right, India.
Okay, so the 3x squared cancel out,
Okay.
and then the negative 4x plus the 9x get 5x.
5x. Perfect. All right, next step. Quiet raised hand. Help me out. What am I doing now? Cheyenne. Okay, negative 19. Perfect. That was the next step. Thank you. I'll take the card. Next step is to do what? I have 2 hands. I want to get more of these cards in. Chew, is your card in? It is? All right. Emily, Brian, Oscar, you guys still have cards? Oh, Colby has your card. Yeah, go for it.
Put 5 up on the top, and it will be 5x. Negative 5x plus 15, right?
Oh, because you're already switching the signs for us? Yeah, you did like 3 steps at once, so you're correct. Yes, thank you. I'll take that. I'm going to go backwards so that people can follow the work, though. So Colby saw if I multiply by 5, a positive 5, so I'm going to put a plus 5. Positive 5 times x is 5x. Positive 5 times negative 3 is negative 15. Can you please not play with that? Thank you. And then Colby also saw that he needed to switch the signs, and he did that already for us. After switching the signs, it becomes a negative 5x, and it becomes a positive 15. I need another quiet raised hand to give me the new line. What is the next step? I have almost everyone participating already. I need more people, though. I think there are 3 people that still have their cards out. No? All right, Ellery.
You'll have negative 4 because negative 19 minus 15.
Yep. And I'll stay with you, Ellery. Negative 4. What am I going to do with that negative 4?
So that's your remainder, so you're going to put negative 4 over x minus 3.
There it is. There's our answer using long division. Is it a question, Anna?
Yeah, yesterday, were we doing the same thing except it has, like, an easier way to do it because only one term?
Exactly. Yesterday we were only dividing by x. Now we're dividing by linear terms like x minus 3. So it's a little bit harder. You can use long division on yesterday's problem. Is it a question, Oscar?
Yeah.
Go for it.
On the plus 15, how'd you get that?
The plus 15? All right, so once again, Colby saw that if I multiply by 5, it'll get a 5x right here. So 5 times x was 5x. 5 times 3 was negative 15. And then we switched the signs to be a negative 5x and then a positive 15.
That makes sense.
Yeah, I'm sure you weren't the one that had that question. Thank you for asking it.
Woo!
All right. So from there, I'm going to show you another way of doing it, and you guys get to pick your own method. I'm not going to force your hand to do one method or the other on a test, on a quiz, on the homework. You guys get to choose whatever works for you. Bless you.
Did you say you could use that one for every problem?
You can use this one for every problem. That's why I teach it, because if you don't know what to do, always do long division.
You said I could?
It's the other method that you
This other method that I'm about to teach you, matching the first 2 terms, that one, you have to adapt it. It's not a clear method like I can write a procedure out for it. All right, so matching the first 2, match the first 2 terms, thank you. I am going to ignore the negative 19. I'm only going to look at the first 2 terms, and I ask myself, what are 2 things that multiply, 2 binomials that multiply such that I get a 3x squared and a minus 4x? And you might be thinking, oh, that sounds like an advanced ninja star. And it is, but in your head. So again, a 3x squared.
Wait,
We're okay over there, Sam? Talking about math? So this 3x squared, we don't know what's happening up here, so we could say it's 3 times something. We don't know what this something is. We know that the bottom has to add up to negative 4. I know that this is going to be 3 and 3, 3x and 3x. What times what will give you 3x squared minus 4? And you can choose whatever you want, which is kind of the nice adaptability of this problem. I can choose anything I want as long as it's a multiple of 3 on the top and as long as it adds up to negative 4. Does anyone see something that has a multiple of 3 when I multiply and something that adds to negative 4 on the bottom? Caroline? Negative 3 and negative 1. That's perfect. Negative 3 and negative 1 works because when I do negative 3 plus negative 1, I get negative 4. Half of that has been done. Negative 3 times negative 1 is a positive 3, which is a multiple of 3. 3 is a multiple of 3. And then I need to reduce. Quiet raised hand here. Who can reduce the left-hand side for us? Go for it, India.
It's going to be x minus 1.
X minus 1. Perfect. So that means our 2 factors were x minus 1. Everyone write it down. X minus 1 and 3x minus 1. The problem with that is that it isn't getting us our last term. Again, we made up our own advanced ninja star over here on the left, and it works for the first 2 terms, but it doesn't work for the last term. Is it a question?
Yeah.
Alright.
So you just did the advanced ninja star with the first 2 terms of the numerator.
Exactly. Notice what number you're going to get at the very end. Essentially what you do is you're going to ignore the first term, I'm just going to do negative 1, negative 1. Everyone's going to shout this one out. Negative 1 times negative 1 is a positive 1. Positive 1 is not negative 19. Positive 1 is not negative 19, but what do I have to do to 1 to get to negative 19? If I have 1, what do I have to do to it? What operation right here will give me negative 19?
Negative 9.
Times negative 19. I'm looking more for a plus or a minus, though, if I add or subtract something. And you guys can shout this one out again.
20.
Minus 20. Which means over here I have a remainder of, and it's not going to be exactly the same over here. Oh, I'm realizing the mistake, and you guys are going to hate me for it. No, there it is. So the problem with this is that we need to make sure that one of the factors, because these are the two factors, right? We're all nodding our heads. These are the two factors. We need to make sure that one of the factors is x minus 3, which means we can actually fill in more parts of our ninja star. So let's draw our ninja star one more time. And we can draw underneath because we basically need no more room to do this. We basically have it right here. I also have watched Big Mouth. From here, I'm going to do another advanced ninja star where I know that over here I'm going to have x minus 3. And because I know that I also have a 3 here, I know that I need to multiply the top and bottom by 3. So this is really going to be 3x minus 3. Or sorry, 3x minus 9. I forgot to multiply by 3 there. This needs to be 3x minus 9. Let me repeat why. We know that one of the factors is x minus 3. This reduces to x minus 3. That is one of the factors. Now we can fill in the rest of the ninja star. We know this is 3x and this is 3x, just like our previous ninja star. We know that it has to be some multiple of 3. We know it has to add up to, what was it, negative 4. Now your problem is what plus negative 9 gives you positive or negative 4, and that's a pretty straightforward question. What plus negative 9 will give you negative 4?
But doesn't that also have to be
A multiple of 3? It is, yeah. 9 times 5 is 45. 45 is, what is that, 15? Yeah, thank you, Colby. It's 15 times 3. So that means if I come back up here, one of the factors had to be x minus 3. Again, this 3x minus 9 reduces to x minus 3, which is where this x minus 3 came from. Can someone give me a quiet raised hand? What should the other factor right here be? Only 2 hands. That's not a good sign. Again, the question is, if this x minus 3 was this factor, what is this factor right here? The right side factor. Colby?
I'm stretching.
That was a good stretch. I was hoping I would get you again. Beverly?
3x plus 5.
There it is, 3x plus 5. We're basically done. We have one tiny step and then we're all the way done. Our tiny step is just like we were doing before. I need to make sure that I have negative 19 here, but I don't. I have negative 3 times 5, which is negative 15. How do I get from negative 15 to negative 19? What do I have to add or subtract? That's it? Oh, I thought that was a hand. What do I have to do to get from negative 15 from the negative 3 and 5? What operation, adding or subtracting, do I have to do in order to get to negative 19? Colby?
Minus 4.
Minus 4. And there is the remainder. Minus 4. Which means the answer is the thing that we found that wasn't the x minus 3 because we divided by the x minus 3, and it's plus 4. So it's going to be 3x plus 5. It was this right-hand side that we were finding with a remainder of minus 4 over x minus 3. And I know what you guys are going to say. Well, obviously you're going to say, well, Mr. Sindel, you messed up when teaching that, and I'll agree with you. Secondly, I should say that I've never taught this method before, but it was just something that I thought might help some of you. And then thirdly, I will say there is a shortcut to all of this.
Why would you not just do it?
Wait.
Because I need to show you all of the math. It's
What
happening.
happened to the x minus 3?
The x minus 3.
Yeah, why is it?
This x minus 3. This x minus 3. Thank you. This x minus 3 has been divided out. It is now canceled out. I have an x minus 3 on the top and an x minus 3 on the bottom. They are canceled out, and I'm left with a 3x plus 5 with a remainder of negative 4. I need that negative 4 because originally I had negative 15. To get to negative 19, I needed the negative 4. Yes, Ellery.
Shouldn't this answer be the same as the long division one, except the long division? Never mind.
It should be exactly the same.
I just
You
wrote,
read it.
I just wrote it down. I put.
Question, Beverly?
Wait, how did you get negative 9 again? Like, you said that it had to be negative 9.
So we know that this factor had to be x minus 3 because it needs to match with this factor. Which means if I'm going backwards with the ninja star, this needs to be x minus 3. but I also know that this has to be a 3x because the leading coefficient here was 3x. In order for this to be... Oh yeah, go for it.
So the top, okay, so there has to be 3x right there because it's 3x right there, right?
Yes.
So then,
I multiply the top and bottom by 3 to go backwards to get 3x minus 9. It's just another way to do this problem, and I'm feeling that because I taught this wrong from the very beginning, very few of you are going to do it, but let's talk about synthetic division. I can get the same answer with about 1/5 the work. And I'm thinking a lot of you are like, oh, this is the method for me. This is why I'm here. All right, so it's called synthetic division, and I love it. I love it because you're doing the same math that you're doing with long division, but in a more condensed form, and you can be brainless when you're doing it. You're just like, just carry, then do this, and then do this procedure, and boom, you get the answer. It's so nice. I love it. All right, so synthetic division only works when dividing by a linear term. Again, let's define this. What is a linear term? Quiet raise hand. Who knows what a linear term even means? Linear term. Colby.
One of these polynomials.
Say again?
One of the polynomials.
It's one of the polynomials that I'm using. It means that I have something like 3x or 2x or just x or negative x. Something that is not linear is something like 1 over x or x squared. Linear term just means that you have a coefficient, a power of 1. So linear term, that's a power of 1. And I will give you guys this as well. For this entire unit, I'm only going to give you linear terms. So this will always work. And it also has to have a leading coefficient of 1, meaning the only things you're allowed to divide by are x plus 3, x minus 4, x plus 7. I will never ever give you something like 7x plus 3. I will never ever give you something like x squared plus 1. Not yet, at least. These things will break synthetic division. All right, now that you guys have an understanding of what you're allowed to do with synthetic division, here it goes. So take this term right here where I have x minus 3, switch the sign, negative 3 becomes a positive 3, and I'm going to put that on the top left. This is now a positive 3. And then you can make a little box to say, okay, that's the main thing that I'm going to be multiplying by. So top left is a positive 3. On the right-hand side here, I'm going to list all of the coefficients. I have 3, negative 4, and negative 19. So I'm going to list those coefficients again. Again, you might need a placeholder, but 3, negative 4, negative 19. 3, negative 4, negative 19. And then I'm going to give myself some room right there to write some numbers and write a line.
Wait, and you can just switch the sign?
You have to switch the sign. You have to switch it.
And what if it's already a plus?
Then you switch it to a negative. The sign has to change. Can we all make that note as well? The sign here changes. Sign changes. It has to change. It has to flip from a negative to a positive or from a positive to a negative. From there, it's the same procedure over and over and over again. Here it goes. And I'm going to go fast. 3. Bring it down. It's still 3. Every time that you jump over the line upwards, you're going to multiply by this number in the top left. So when I'm jumping up here, I'm now multiplying. This number 3 times 3 is, shout it out. 3 times 3 is 9. Every time I jump upwards diagonally, I multiply. So you can have a multiply symbol. Whenever I go down, I just add. Negative 4 plus 9 is 5. I'm going to multiply straight up diagonally again. 5 times 3 is 15. I add straight down. Negative 19 plus 15 is negative 4. You're basically done at this point. You're basically done. The last number will always be your coefficient, or your remainder, sorry. The last number is always your remainder. If your last number is 0, you have no remainder. So the last number is always your remainder. So this thing is always going to be divided by x minus 1. This number is always going to be your constant. And this number is always going to be your x. This number is always going to be your x squared. This number is always going to be your x cubed. This number is always going to be your x to the 4th. But we didn't have any numbers over there, so we don't have any x to the power 4. We don't have any x to the power 3. We don't have any x to the power 2. Your final answer is 3x. This was a positive 5. 3x plus 5 with a remainder of negative 4 over x minus 1. That is the same answer that we've been getting up here. 3x plus 5 with the remainder of negative 4 divided by x minus 1. Look how fast that was. Look how little work we did. I'm going to try this one more time with you guys on the back. I'm going to guess that most of you like synthetic division. Is it a question?
Yeah, minus 1 on the.
On the bottom, down here?
Yeah.
So this came from our original problem, which is all the way up here. Oh, yeah, it's a teacher error. It should be x minus 3. Thank you, Anna.
Oh.
Another one? You're just handing these things out, Mr. Simba.
It should be x minus 3 right here. I don't know why it was an x minus 1.
Show you how
And
to
then,
take.
Yeah, it's up at the front. Let's do example number 2. Question.
one more time. Where did you get 3 from where you have to change the sign?
This 3 came from this 3 right here, but switching the sign. All right, we're going to go through this one more time, and then you guys are on your own for example number 3. I'll help you set up example number 3, but then you're going to do it. All right, so I'm going to take this negative 2, and I'm going to switch the sign. It's now going to be a positive 2 in the top left. What are my coefficients? Someone shout them out. Just shout them.
2, 3, negative 10.
2, 3, negative 10. Draw your line. Bring the first one straight down. 2. I'm going to do what in order to go up to the top right? Shout it out.
Multiply by 2.
2 times 2 is
4.
4. I'm going to add these together. 3 plus 4 is 7. You go up diagonally yet again.
8.
7 times 2 is
14.
14. I add straight down. I get
4.
4. I was originally dividing by x minus 2, so this is always going to be my remainder. This remainder is 4 divided by x minus 2. This is the constant term. This is the x term. We don't have any x squared terms. We don't have any x to the power of 3 terms. So my final answer, you have to rewrite it, is 2x plus 7 plus 4 over x minus 2. Question, go. I think it's a positive 4 because negative 10 and a positive 14 makes it a positive 4 here. Thanks for checking that though. Any other questions? Is there a question, Oscar?
Yeah. So you know how you do 2 times 2, right?
3 times 2, where do we do that?
2 times 2 to get 4.
2 times 2 to get 4, yes.
Okay, so. Oh, okay, so. Wait, how'd you get plus 2 in the beginning?
How do I get this plus
Yeah.
2? I always take this sign, it was a negative 2,
Okay.
switch the sign, becomes positive.
Okay, so for every problem, is it x minus 2? If it's, for example, this x minus 5, you do plus 5.
Exactly.
And then you multiply all of those bottom ones.
Yeah. And to test your understanding, what if this was x plus 2? This number would be...
Negative.
Yeah.
Makes sense.
Cool. Any other questions? Yes.
Will this work on our homework?
This will work on every single homework problem you have tonight. Some of them will have a remainder of 0 here. Some of them will have a remainder of 4 or 3 or some other number. Let me help you set up example number 3, and then you guys can do it. X squared minus 20 is the same thing as x squared minus 0 or plus 0x minus 20, which means your numbers that you should be writing for your coefficients are 1, 0, negative 20. Some people will make the mistake of just writing 1, negative 20, which will break synthetic division. It will also break long division. It will break everything. Make sure you have a placeholder. It goes 1x squared, 0x, and negative 20. So my numbers down here are going to be 1, 0, and negative 20. I will let you do the synthetic division. Good luck.